Hi viewers, welcome to Sevivali Kalvi channel. Today we are going to see about the counter design. So by using D flip-flops. So this example is one of the question which already came in GATE exam. So really this exam very useful for you how to easily design the counter by using the D flip-flop concept. So first you just read the question carefully. Design a counter using D flip-flops that goes through the state 0, 1, 2, 4, 0. So there are in this question four states are there 0, 1, 2, 4, and again it goes to 0. The undesired or unused states must always goes to 0. It is assigned as 0, 0, 0 on next clock pulse. So this is your question. So from the given state you have to design a counter by using D flip-flops. So you move to solution part. So in step 1, we have to find how many number of flip-flops to be used in this problem. So to find the number of flip-flops, this is the condition 2 power small n greater than or equal to capital N, where the capital N is the modulo value or simply it assigns the number of states to be presented in the particular counter design. So how many number of states must there uh, is mentioned in capital N, or simply some questions modulo 12 counter or modulo 6 counter, likewise modulo values are also given in the question. But in this case this modulo value is not mentioned, so we have to take this capital N is the number of states to be present in this example. So 2 power capital small n is the number of flip-flops. So 2 power n greater than or equal to n is the condition, where small n is the number of flip-flops. So now we have to check how many states are there in this given question. So in this problem, 4 states are there 0, 1, 2, 4. So normally we have the states are in a sequence order 0, 1, 2, 3, 4, 5, 6 likewise. But in this case, initial state is 0 and the next state moves to transition 1. And again, the transition taken place, the one state moves to the next state 2, and from 2 it moves to the next state 4. So these are the four states present in this given example. So from this, a small n equal to 3 is assigned. So then the states repeat and n is not given here. So from this, we understood the total number of flip-flops are used here is 3. So how can we decide this 3 number of flip-flops to be used here is based on this four states. This 4 is included in this sequence state order, because if you take 0, 1, 2, 3, automatically this 0 can be represented by 2 bits 0, 0, and 1 can be represented in 2 bits 0, 1. 2 can be represented as 1, 0, and 3 can be represented as 1, 1. But in this case, 3 state is missing, so it moves to directly 4. So from this, there is no possibility to use the state in terms of 2 bits. So we have to take the number of bits for each and every states are in terms of 3 bits. So for this case, we have to consider the 4 state value can be represented by 100. So when you consider this, automatically number of states present in this example can be considered as 8 states. So that is 0, 1, 2, 3, 4, 5, 6, 7. So out of 8 states from 0 to 7, only 4 states are used states in this example, that is 0, 1, 2, 4. Remaining states are taken as unused states. So because of this reason, here the small n value which is equal to 3, that is number of flip-flops to be used in this example is 3. So from this, we can assign the initial state 0, 0, 0. So that is the starting state. The corresponding state value is 0. So this counter has 4 states, 0, 1, 2 and 4. The corresponding bit or number of flip-flops present for this particular states are represented 0 as 000, 1 as 001, 2 as 010 and 4 as 100. But it requires 3 flip-flops since it counts the 4. So 100 as well as we have to consider it. So 3 flip-flops can have 8 states. Out of these 8 states, 0, 1, 2, 4 are used states. Remaining 4 states 0, 1, 1, 101, 110, 111, that is state 3, state 5, state 6 and state 7. These 4 states are unused or undesired state in this example. So as given in the question, these undesired states always go to 000, that is initial condition, after the next clock pulse arised for each and every cases. So this is the given question explanation. So from this question we observed these all information, so that can be represented in step 1. So next we move to draw the state diagram from the given conditions. So that is step 2. So our initial state is 0. So this can be represented by within the circle and the state value is 0. If you want to mention it in terms of binary digits, that is number of flip-flops to be used in terms of 3 bits, 0, 0, 0 is the state 0 value. Now the 0 state move to next state 1. So the arrow indication is move towards the 1. Next the state 1 is move towards the 2. That is the next state from 1 is 2. So the transition can be represented with the help of this arrow indication from 1 to 2. Similarly, the state transition is taken place from 2 to 4. That is represented in this arrow indication. Again, 4 state to it goes to 0 state. So that can be represented in arrow indication. So these 4 states are used states. So in our condition, we have the 4 unused or undesired states present in this question. That is 3, 5, 6, 7. These all 4 states move towards the initial condition or initial state for every clock pulse to be given for this particular state. So the initial condition 0. The transition from 3 to 0, 5 to 0, 6 to 0 and 7 to 0 can be indicated by this arrow. So these 4 are unused states. These 4 are used states for this example. Next, from this state diagram, we can draw the transition table for D flip-flop through the excitation table. Because in this example, we have to design the counter by using D flip-flop. So we have to consider the excitation table for D flip-flop. So excitation table consists of your Qn value, Qn plus 1 value and D value. So from this excitation table, we can take the remaining values and we can make it as a transition table. So present state, next state and flip-flop inputs. So in present state, in this example, we are using 3 flip-flops. So the 3 flip-flops can be denoted by in flip-flop inputs D1, D2, D3. If anybody want to use ABC, we can consider DA, DB, DC. But in this example, I just take 1, 2, 3. So total 3 flip-flops are used here. So it is assigned as D1, D2 and D3. And the present state values are Q1, Q2, Q3. And the next state values are Q1 plus 1, Q2 plus 1, Q3 plus 1. Now I have to take the present state value 0, 0, 0. Now it is in initial condition. Now what happened when this condition is a present state? What is the next state value? That means from state 0 to 1 transition is occurred that can be represented in the question. So the present state value 0, 0, 0. The corresponding next state value will be 0, 0, 1. That can be represented by arrow indication. So before that, we have to fill all the 8 states value in sequential order 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0 till 111. So from this, for initial condition 000, the next state will be 001, which is already given in this question. So this 001 next state move towards the next state column 001. So similarly, 001 is the present state now. At the time, the next state will be 010, which is mentioned in the question. So the next state will be 010, move towards this next state column. Again, 010 is the present state now. Now, the corresponding next state will be 100, because in this example, the state movements are given or transition are given 0 to 1, 1 to 2, and 2 to 4. So in this case, the present state is 010. What is the next state of this present state? 010. It will be next state. So the 100 is the next state. That indication is mentioned here. And the present state 010, the corresponding next state will be 100, which represent by this arrow indication. And after that 011. So this 011 is the unused state in this example. So for this case, there is no transition among the remaining used states. That means the 011 is the present state. At the time, the next state value will be 000, because in this state diagram we represent 3, 5, 6, 7 are the unused state. These can be moved to the next state of initial condition 0 or initial state 0 for the each and every next clock pulse applied because of unused states. So in this condition, so 011 is the state 3, and this state 3 present state transition, for this transition can be moved towards 0 state. So 000 is the next state for this 011 state. Next we move to 5. The 101 is the next unused state. The corresponding next state will be 000 because of unused state. So this present state 000 move towards the next state 000. Similarly, 110 state also consider here, and the corresponding next state will be 000. 111 is the present state, and the corresponding next state will be 000 because of unused conditions. Now the present state and the next state columns are filled based on this given condition, used and unused states. After that, we have to compare these Q3 and Q3 plus 1. That is the present state value and the next state value should be compared, and based on that we have to fill this D value. So when the Q3 is 0, Q3 plus 1 is equal to 0, the excitation table for D value is equal to 0. So that is mentioned here. Similarly, again Q3 is 0, Q3 plus 1 also 0, the D value becomes 0. Similarly, next Q3 0, Q3 plus 1 is 1. When this condition is occurred, your input is equal to 1. That means simply the present state is not a matter. Which input you are going to give in D flip-flop, that will be the output for the D flip-flop. So that condition is taken here from the excitation table. So next 0, 1. So the Q3 is 0. Again the Q3 plus 1 is 0. Our D input value becomes 0. So again Q3 1, Q3 plus 1, the corresponding combination D3 again 0, 1, 0, 0, 1, 0, 0, again 1, 0, 0. So from this only one state, that is 0, 1, 0 present state have the input for the flip-flop 1. Remaining all values will be 0. Similarly, for next case Q2 and Q2 plus 1, we have to compare these two. 0, 0, the corresponding D value 0. When the Q2 0 and Q2 plus 1, 1, our input is equal to 1. Because the present state is not a matter. What input you are going to give in this D flip-flop, that will be your output in next state. So based on this excitation table, the Q2 and Q2 plus 1 are compared. So now the input for the corresponding flip-flop is 1. And 1, 0 condition 0, Again Q2 1, Q2 plus 1 0, 0, and Q2 0, Q2 plus 1 0, input 0. Again Q2 0, Q2 plus 1 0, input 0, 1 0 combination 0, 1 0 combination again 0. So next again compare Q1 and Q1 plus 1 condition. So here initially the Q1 value 0 and Q1 plus 1 value 1. When this condition is occurred, automatically our input is equal to 1, because which input you are going to give in this flip-flop, that will be the output in next state. So the present state is not considered. It may be 0 or 1, the output will be 1 here. Sorry, input will be 1 here. Next Q1 1, Q1 plus 1 0. For this condition D1 is 0, Q1 0, Q1 plus 1 0, D1 also 0, Q1 1, Q1 plus 1 0, again D1 0. Likewise remaining all the comparison value, D1 value becomes 0. Now we have D1, D2, D3, 3 inputs. So from this 3 inputs, we have to make a K-map simplification, and we have to take present states variables Q1, Q2, Q3, and the alignment of 3 variable K-map should be made here, and we have to fill all the values. So first consider this D3 flip-flop. So for D3 flip-flop 0, 1, 0 condition, that is Q3, Q2, Q1. At the time the D3 value becomes 1. So that is mentioned in this cell. Remaining all cell values are 0. So we put all 0 here and put 1. And this in this example, there is no possibility to make a octet mapping or quad mapping or dual mapping, etc. So there is only possibility to map a single map. That is only 1 is present. So this 1 is individually mapped or grouped here. So this is located in first row and fourth column. The corresponding variable should be considered Q3 and Q2, Q1. The Q3 values variable 0. So simply the 0 can be represented as Q3 bar. So Q3 dash can be represented here. And Q2 variable, the value, binary value is equal to 1. So Q2 as represented as usual Q2 because of 1. And Q1 corresponding value is 0. So it is mentioned in terms of bar. So Q1 bar. So the expression for this single bit mapping Q3 dash Q2 into Q1 dash is the expression for D3. Similarly, we have to find the K-map for D2. So in this case, the D2 input is high when 0, 0, 1 for Q1, Q2, Q3. So the corresponding cell is filled by 1 and the remaining all cells are filled by zeros. And here also we are individually mapped this 1. So the first row and the second column is considered for mapping, and Q3 bar, Q2 bar and Q1 is the expression. So Q3 bar dot Q2 bar dot Q1 is expression for D2. Similarly for D1, the 0, 0, 0 condition, the input value D1 is equal to 1. Remaining cell values are 0. So it is individually mapped here. And first row, first columns are considered. The corresponding expressions will be D1 is equal to Q3 bar dot Q1 bar dot Q2 bar. So the D1 also found here. So from this D1, D2 and D3, finally we can draw the counter using D flip-flops concept. So here you have to take a 3 flip-flop and these are all named as A, B, C, and the corresponding values are, you can take A, B, C or 1, 2, 3. Here D1, D2, D3, Q1, Q2, Q3, Q1 bar, Q2 bar, Q3 bar. Likewise, we have to mention all those things. And this is synchronous counter. So the common clock pulse should be given for each and every flip-flop for this example. So in this example, 3 flip-flops are there. So all the flip-flops are having the same clock signal with the same frequency. So that can be represented here. So in this example, what is the D1 value? Q3 bar, Q2 bar into Q1 bar. So first we can take Q1 bar answer and Q2 bar answer. Again Q3 bar answer. So the every answer will be taken and the corresponding values are AND together, and it will be sent to this D1 concept. So now the multiplication of Q3 bar dot Q2 bar dot Q1 bar can be represented by this AND gate, and that output is given to the flip-flop 1 D1 input. Next, D2 is equal to Q3 bar dot Q2 bar dot Q1. The corresponding result can be observed from this gate. So here Q3 bar can be taken from this line. Again, Q2 bar can be taken from this line, and Q1 is there. Directly, this Q1 is connected with this line, and three inputs are joined in a single AND gate, and the corresponding output is given to D2. Next, D3 is Q3 bar dot Q2 into Q1 bar. So, D3 is taken from Q3 bar and Q2. Already these lines are we have taken, and Q1 bar, every lines are joined together, and the corresponding output is now connect with this D3 input. So this is the designing of counter using D flip-flop. So whenever you want to design these kind of counters, it may be JK flip-flop or D counter by using JK flip-flop or D flip-flop, T flip-flop, SR flip-flop. We must have this expression. From this expression only we can able to draw this implementation or designing of this counter at last by using flip-flop concept. So I hope everyone understand this concept clearly, how to design a counter by using D flip-flop in this example. So keenly monitor this example. So this is the one kind of question which already asked from gate questions. So solve it properly. If you have any doubt, kindly you can give some comments in the channel. Thank you all. Subscribe my channel. Thank you.